Alright, for this reassessment, we're going to be focusing on circular motion. In the problem, it states Landon and Jocelyn are partners in pair figure skating. Last weekend, they perfected the death element for inclusion in their upcoming competition. During the maneuver, Landon holds Jocelyn by the hand and swings her in a circle while she maintains her blades on ice stretched out in nearly horizontal orientation. We're asked to determine the net force which must be applied to Jocelyn. Her center of mass rotates in a circle with a radius of 61 centimeters once every 1.9 seconds. So from the problem, we first have to identify what do we know. We know that Jocelyn's mass is equal to 51 kilograms, and we know the radius of the circle is 61 centimeters every 1.9 seconds as she's rotating around the ice. So from the problem, it states, what are we trying to find? We want to be able to find the net force that should be applied to Jocelyn if her center of mass rotates in a circle with a radius of 61 centimeters every 1.9 seconds. So from the problem, flip to the next page. Kind of some formulas that we wrote down. We know that the net force is equal to our mass times our acceleration, and then where our acceleration is our velocity squared divided by our radius. So in order to first solve the equation, we have to figure out what is the speed. So in order to determine the speed, we know that a radius of a circle is 2 pi r. So we take our 2 pi r and we are going to divide it by the time it took to rotate in a circle of 1.9 seconds. So when we do this, we get a speed of 2.0172 meters per second. So from our speed, we're then going to go down and try to figure out our acceleration. So from our equation, we know that acceleration is velocity squared divided by our radius. And as you can see, instead of meters per second, I put my radius in meters just to make our equation a little bit easier. So we have our speed, which we take from our first problem in which we solve in order to solve for acceleration. So we have 2.0172 squared divided by our radius of 0.61 meters, and we get an acceleration of 6.6709 meters per second squared. So from our acceleration, we know that our F net equation is our mass times our acceleration. So from the problem, we know that Jocelyn's mass was 51 kilograms. So we're going to take our 51 kilograms and we're going to multiply it times our acceleration of 6.6709 meters per second squared. And our final answer is going to be 340 newtons if we round that to the nearest number. So from that, we found where we were able to determine the net force. And in order to solve for our net force, it's kind of important that we know how to calculate for speed, acceleration, and once we get those two variables, we are able to plug that into our equation for our F net and get what the net force was in newtons. So pretty much a kind of simple problem, lays down how to calculate for speed and acceleration, and from that we can plug in our F net equation and get our net force. So that's pretty much it on our circular motion reassessment, and I look to do more in the future. Thanks.